All right, here we go, continuing our trek into sine and cosine. In the past, we talked about graphing the equations for sine and cosine, but now we're going to be given a graph and we're going to be writing the equations for each of these. So take a look at some of the examples below. If you're following along with me, these are the notes on page 41 in our notes packet. Take a look at some of the examples below. Here I have some sine and cosine waves. Now, you might notice that this is only one cycle of each of these waves. So you can actually go ahead and just draw in the arrowheads on either end of each of these cycles to just denote that this does continue. These are periodic functions. So this pattern continues all through for all x. Okay, so we can draw in those arrowheads. All right, so I just want to do a quick review of the general form for the sine and cosine equations. Here we have y equals a sine or cosine of b times x minus h, all plus k, where this quantity here is the argument of our sine or cosine. Okay, this is true for both of them. So each of these values here, a, b, h, and k, denote a different transformation. So we see that the number in front, a, represents our amplitude. B, out in front of our x term, it's not our period, but it helps us find our period. So I'm going to write period, but I'm also going to write how we find the period from B, and that is in radians, 2 pi over B. X minus h, well, that h is our horizontal shift. And then at the end, the plus k is our vertical shift. And that's true for both sine and cosine. So A represents our amplitude, B helps us find our period, H is our horizontal shift, and K is our vertical shift. So using those transformations, let's go ahead and write the equation given one cycle of the graph. So for number 1, I see that we've got this wave here. It starts at the midline, hits a max, hits a midline, minimum, and then returns to a midline. I'm looking at this and I'm thinking this is the positive sine graph. Now, in order to find the amplitude, we have to determine what are the max and min. Well, we have a max all the way up here. We have a max of 4 at x equals pi halves. We have a minimum all the way down here at negative 4. So our max is 4, our min is negative 4. We can find the amplitude. And I'm going to just write this off to the side. Our amplitude can be found from the max minus the min all over 2. So take your max 4, subtract the minimum, negative 4, and divide it by 2. And we find we have 8 over 2, or just 4. And that should make sense with our graph. That is the distance, the maximum distance of our curve from the midline. All right, we see that our midline is directly in between our max and min. In this case, it is the x-axis. We have a midline of y equals 0. Our vertical shift is determined by our midline. Well, we're not shifting up or down at all. Our midline is the x-axis, so there is no vertical shift. Our period, so we see we start at 0 and we continue. We hit pi halves. This would be, if each increment is pi halves, then the second one would be 2 pi halves or pi. The third would be 3 pi halves. And the fourth would be 4 pi halves or 2 pi. So we see that the length of one cycle before it repeats, or the period, is from 0 to 2 pi. So we get 2 pi. We can use our period to find our b value by setting up an equation. Well, we know our period is 2 pi. We know that the period is also 2 pi over b. So that would mean that once we get to our equation, b is 1. Our horizontal shift, well, again, we're starting at 0, so the beginning of our first cycle isn't shifted right or left at all, so we do not have a horizontal shift. So let's go ahead and write an equation. We're going to write it in the form y equals, our amplitude A is 4. This is a positive sine curve. We start at the midline and then go up and hit our max, so we're going to write sine. Our period is 2 pi. And by setting up this equation, we have that b equals 1. So we can write that 1, or you don't have to. We don't have a horizontal shift, so we can just say that the argument of the sine is x. And then a vertical shift, we don't have any, so we don't have to write plus or minus anything at the end. So our final equation is y equals the 4 sine of x. And you can plug that into your calculator just to double check. Let's try a couple more examples. Here we have this wave here starting at a max, ending at a max. I'm thinking positive cosine. So I see that our maximum is, if this is 1, then this is 2. We have a minimum all the way down at negative 2. So that means that our amplitude is 2. Our vertical shift, well, we're not shifting up or down. Our midline is still on the x-axis. So our vertical shift is none. Our period, the length of the cycle before it repeats, we start at 0. This is pi halves. So then an equal distance more is 2 pi halves, or pi. So then our period is pi. And again, we start at x equals 0. So we do not have a horizontal shift. To write our equation, we have y equals a. A is our amplitude, 2. We're graphing the positive cosine. B, well, we need to find b, so let's set up our equation. We know period is 2 pi over b. So b equals 2 pi over pi, or just 2. We don't have a horizontal shift, so there's nothing added or subtracted to our x term. And we don't have a vertical shift, so there's nothing added or subtracted at the end of our equation. So this is our final equation here, y equals 2 cosine of 2x. I got 2 more examples for us today. Here we have another curve, and I see we start at a minimum, we go up, hit a maximum, and end at a minimum, so I'm thinking negative cosine. I see we have a maximum of 1 at pi halves, and a minimum of negative 1 at negative pi halves and 3 pi halves. So let's go ahead and label these x values. If each increment is pi halves, then in the negative direction we must have negative pi halves. Another would be pi, and then 3 pi halves. Our amplitude, the maximum distance of our curve from the midline, is 1. Our midline is, again, the x-axis. So we do not have a vertical shift. Our period, we're going from negative pi halves to 3 pi halves. So that interval has width 2 pi. Okay, from negative pi halves all the way to 3 pi halves has width 2 pi. And our horizontal shift, well, I see we start the cycle at negative pi halves, so we're going left pi halves. So let's go ahead and write the equation. We have y equals our amplitude 1. We have the, and you can write that 1, you don't have to. We have, this is the negative cosine, so you can write negative cosine of b. Well, we need to find b. Our period is 2 pi. And again, you could set up that equation 2 pi over b, but you might also know that the regular period of just the parent function of cosine is 2 pi. So there is no transformation for b. So that would be 1. We have a horizontal shift, left pi halves. So remember, a shift to the left would mean that we are adding pi halves to our x term. And we do not have a vertical shift. So our equation, y equals negative cosine of x plus pi halves. And last but not least, we have another graph starting at the midline, hitting a max, midline, min, midline. So I'm thinking positive sine. So our amplitude, I'm going to just go ahead and draw in our midline. Our amplitude is that maximum distance. Well, if our max is 2 and our minimum is 0, then our amplitude is max minus min over 2. So max minus min over 2, or 2 minus 0 over 2. Well, 2 minus 0 is 2, over 2 is 1. So our amplitude, that maximum distance of our curve from our midline, is 1. Our vertical shift, it affects our midline. So how much vertically is our midline shifted? Well, we go up 1. So our midline has the equation y equals 1. Our period, let's take a look at our x values now. This is 0. If one mark is pi thirds, then in the negative direction, we must be at negative pi thirds. Another mark in the positive direction would be 2 pi thirds. So our period from negative pi thirds to 2 pi thirds is a total distance of 3 pi thirds or pi. Our horizontal shift is to the left pi thirds. That's where our cycle begins. So we have y equals our amplitude 1. And again, you can write it, you don't have to. We're looking at the positive sign of, or our period, we need b. So we use our period. Our period is 2 pi over b. And solving this equation, we get that b equals 2. So 2 pi over pi is 2. And then we have our horizontal shift, left pi thirds. That's going to be an x plus pi thirds. And finally, we have a vertical shift up 1, so we add 1 at the end. And that's our final equation. All right, we're going to get a whole lot of practice on this in class. This is writing the equation of sine or cosine given a graph. We'll see you tomorrow in class. Bye, everyone.